Okay, you're given 3 points in space and asked to find the equation of the plane containing those 3 points. For purposes of discussion, I've labeled the points P, Q, and R. And to find the equation of a plane, we need to have a point, which we have 3 to choose from, and a normal vector. To find a normal vector, we need to find 2 vectors in the plane and then find the cross product of those 2 vectors. So the easiest thing to do is to maybe use vector P as a starting point and find vector PQ and PR. And so QR would be 0 minus a negative 2. That's the x coordinate. PQ, 0 minus a negative 5, 3 minus 0. So there is vector PQ right there. And vector PR, following the same pattern as that. And to get the cross product, set up this determinant. This is just a memory device. You're not really evaluating a determinant. And I could have little vector symbols up here. But you could do this by expansion by minors. So using this element, I take that element times this determinant, which is 25 minus 18. Then for J, which is in the first row, second column, that means I have a negative sign here because the sum of the column and the row is odd. So minus J times its determinant, which would be the 2, 3, 2, 5. And same thing for K, 12 minus 10. So there is the normal vector for these 2 vectors right there. And that's what this red arrow, red vector pictures there. And you can see the points are lying in that plane. So there's your answer right there. Coefficient of 7, if you happen to end up with something other than the 7 there, you could just multiply every term by whatever value and turn that into a 7. And I'll just mention that another way to evaluate this 3 by 3 determinant is to add 2 columns. The first 2 columns, the red arrows or the red lines are pluses, and then subtract the product of the green lines. You get the same thing. Okay, there you go. Hope that helped. If you have any questions, post a comment.